This is the radio. I brought it back out again. You can see I changed things around a little bit. I put the main board on top of the RF output board, and this is the oscillator. I couldn't get the oscillator working. I tried about 10 or 15 different versions of it, so I ended up getting a kit off the internet, which I'm waiting for it to arrive in the mail, and I'll continue with it. The main board is on the second tier above the power amp for the driving the antenna, which you can't really see, but that's a tested circuit that's working good. Some of the oscillators I tried to use crystals, and some didn't, but I couldn't get any of them to operate the right frequency, so I ended up ordering the kit. You can see here, this is the main board. That's the DB25 connector that I used to connect. Also, along with that, a Molex connector connects the board to the chassis mount parts. The Molex connector is right there, and it connects to the chassis mount parts. Like, for example, the transmit receive switch, the pots for IF gain, and that's the IF gain pot there, and that's the audio gain pot, audio volume. Let's see, these are that's the microphone connector on the left and the antenna connector, and those are the two tuning capacitors. Well, they're both area variable. One's a 14 to 380 picofarad capacitor. The other one, I can't remember the value, but it's a smaller value. It's for fine tuning. This is the relay board to switch between transmit and receive. You can see the relays there if I can get them in the right position. Those are the two relays. Some of the switching is done by the four-pole switch, double throw. That's the audio board. It's based on an LM386. It can drive a speaker or a set of headphones. And then I'll show you the RF input amplifier. That's that right there. Uses two N 394 transistors. They might have been 2N 2222s. They're about the same. You can see the mix. One of the mixers there. There's one of the mixers with the diodes and the transformers, and the other one is up in this area right there. These are the two fed buffer amplifiers. They're based on surface mount parts, which I had to solder in with wires very delicately, and they work good. Let's see. This is where the IF section is. These transistors in this area are the IF amps there. 304s are 22s also. And that's, you can see, that's the filter. That's the crystal oscillator for the transmit IF. I tried to use circuits for more than one purpose if I could, to save on the parts count and the costs. So I used one of the mixers and the IF section for both transmit and receive, with a lot of switching, either switch and the relays. And I'll have more for you when I get the oscillator kit in the mail. I'll have more information then. Thank you very much. You can see a couple of the other oscillators I built here. This is one that this is one of the ones I did with crystals on it. Did so many, I can't remember which one this is. It's probably a Colpitts oscillator with crystals to stabilize it, the DXO of some kind. And all of them I didn't save. I just rebuilt on the same board. I threw the board away. All of them got thrown away. Here's one with a tank circuit, another oscillator. This is the previous version of the transceiver that I designed, built, but I never got it working. Had problems with the outlook. I made a mistake in the layout. That's where it connected to the ground. It shouldn't have been. And this is the other boards from the group that I had made for the more recent version that I'm working on now. I tried reworking the amp for the microphone a little bit there, putting a buffer on the output. I reworked the oscillator a little bit, tried to make my own coil out of it, to let people roll, see if we can get a better frequency. was thinking about trying to use this circuit here, this QSD magazine from ARRL as the VFO instead of the kit, so I can have it be more self-made. But I think I can make it work at the right frequency by cutting the inductance value in half, changing the frequency by square root of 2 to make it about 10 megahertz instead of 7 megahertz. I'm using a 10 megahertz local oscillator and an IF of 3 megahertz. I'm not sure if that alone would do it, and I'd have to buy all the parts, which is not a good option right now. I don't know whether it would work or not, but just wondering if that would work. Might give it a try, I'm not sure. Hi Jim and Pat, I got the bugs out of that circuit board, and now the problem I'm faced with is basically it's transmitting but not exactly pinpointing around the correct frequency, so I've been trying to get the oscillator to behave right, and it's been unruly. A guy at the ARRL website recommended I rebuild the oscillator, so I started rebuilding it there in a little circuit board, and I have to get more parts. Once I get that working, I think everything else is working. I'm getting sound out of it, but not actually voices or anything, just the hiss, but it's getting sound through the system anyway. So, back at it, it looks like a terrible mess, but that's because it changes so many times, but I just hope it works, that's the main thing. But, that's about it. I'll talk to you later. So, Patty and Jim, you can hear the sound it's making coming from over there from the computer speakers. You can try to tune something in. You don't get anything, but, the audio section's working good, and I haven't used the antenna. The antenna's broken, so I'll send you another one showing the transmitting. This shows you how it transmits. This is tuned to about 7.4 megahertz. Should be down between 7.0 and 7.3. And yeah, you get feedback. I was getting it. So it is transmitting, it's just not quite the right frequency. 7.4, it should be down on 7.0, 7.3. You can see here I built that kit. Try to get in the light. I'll open the shades. That's the oscillator kit. Try to get it so you can see it. I don't know if it's working. I don't have any way of measuring it. Not getting anything intelligible out of it yet, but that's the mic amp that controls the modulation. I reworked that because the other one was having spurious oscillations. I used too fast of an op amp, and it was trying to do capacitive of a load, and read the spec more carefully, and that's what happened. So it was a 741, and I changed the. I didn't change it yet, but I ordered a transformer to replace that one there, T7. So you want it to drive as high of an impedance, as low of an impedance, this mic amp. So I don't need the buffer amp. I just need the 741 circuit. And I'll get that transformer in a couple of days, so we'll see how it works.